Very good morning, student. The next topic is definition of power. Definition of power. The power is defined as rate of work done or energy delivered. This is the important 2-mark question. Please note it down. Power is defined as the rate of work done or energy delivered. So what is the formula for the power? Power P is equal to work done W divided by time taken T. W by T. So P is equal to W by T. The next, average power. How will you calculate the average power? First of all, we should know about the definition of average power. Average power is defined as PAV. It is represent average power is defined as the ratio of total work done to the total time taken. So P average is equal to total work done divided by total time taken. So P average is equal to total work done divided by total time taken. The third power is instantaneous power. Instantaneous means continuous. Instantaneous power is defined as the power delivered at any instant. That means power delivered at an instant as time interval approaches 0. So continuous process is nothing but instantaneous power. Power delivered at an instant as time interval approaches 0. Instant power, instantaneous power is equal to dW divided by dt. So once again repeat, what is meant by definition of power? Power is defined as the rate of work done or energy delivered. Power P is equal to work done W divided by time taken T. So P is equal to W by T. The next power is average power. Average power is defined as the ratio of the total work done to the total time taken. That means average power is equal to total work done divided by total time taken. The third power is instantaneous power. The instantaneous power is defined as the power delivered at an instant as time interval approaches 0. Instantaneous power is equal to dW divided by dt. Then important topic is unit of power. So what is the unit of power? Power is a scalar quantity. So this is very important objective type question. Please note it down. Power is a scalar quantity. Its dimension is ml square t power minus 3. Please note it down, children. Dimensional unit of power is capital M, capital L square, capital T power minus 3. The SI unit of power is watt. SI unit of power is watt. Named after the inventor of the steam engine James Watt. 1 watt is the defined as this is the definition of 1 watt. Please note it down. This is also important 2-mark question. 1 watt is defined as the power when 1 joule of work is done in 1 second. 1 joule of work is done in 1 second is nothing but 1 watt. So 1 watt is equal to 1 joules per second. The higher units are kilowatt kW, megawatt MW and gigawatt GW. 1 kilowatt is nothing but 1000 watt. That means 10 power 3 watt. 1 megawatt is nothing but 10 power 6 watt. 1 gigawatt is nothing but 10 power 9 watt. So for motors, engines and some automobiles, an old unit of power still commercially in use, which is called as the horsepower. That means HP. We have a conversion for horsepower HP into watt W, which is 1 HP is equal to 746 watt. This is very important point, children. Please note it down because this is 1-mark question. 1 HP is equal to 746 watt. All electrical goods come with a definite power rating in watt printed on them. A 100 watt bulb consumes 100 joules of electric energy in 1 second. Once again repeat, a 100 watt bulb consumes 100 joules of electrical energy in 1 second. The energy measured in joule in terms of power in watt and time in 1 second is written as 1 joule is equal to 1 watt second. 1 joule is equal to 1 watt second. Please note it down, children. This is one important objective type question. 1 joule is equal to 1 watt second. When electrical appliances are put in use for long hours, they consume a large amount of energy. measuring the electrical energy in the small unit watt second Ws leads to handling large numerical values. Hence, electrical energy is measured in the unit called kilowatt hour. That means kWh. 1 electrical unit is equal to 1 kilowatt hour. 1 kilo means 10 cube watt into 1 hour. How much second in 1 hour? 3600 second. So 1 electrical unit is equal to 3600 into 10 power 3 watt second, or otherwise says 1 electrical unit is equal to 3.6 into 10 power 6 joule. Because 10 power 3 here the full stop which is placed in a 3 before 3 numerical value. So 3.6 into 10 power 6 joule. So 1 kilowatt hour is equal to 3.6 into 10 power 6 joule. So the electricity bills are generated in units of kilowatt hour for electrical energy consumption. 1 unit of electrical energy is 1 kilowatt hour. 1 unit of electrical energy is 1 kilowatt hour. Please note it down, children. This is very important point for your objective type question. 1 unit of electrical energy is 1 kilowatt hour. Note, kilowatt hour is unit of energy and not of power. The next topic is relation between power and the velocity. Relation between power and the velocity. The work done by a force F vector for a displacement dr vector is work W is equal to integration of F vector dot dr vector. Left hand side of the equation 4.4 can be written as this. Left hand side of the equation W can be written as integration of dW is equal to multiple and divided by dt. So integration of dW divided by dt into dt. Since velocity is v vector is equal to dr divided by dt, because what is the definition of velocity? Velocity is nothing but rate of change of displacement. So here displacement, rate of change of displacement is called dr vector divided by dt. So v vector can be written as dr vector divided by dt. Here in this step dr vector can be written as v vector into dt. V vector into dt is nothing but dr vector. Right hand side of the equation 4.46 can be written as this. Right hand side equation can be written as v vector is equal to dr vector divided by dt. So f vector, right hand side equation is nothing but integration of f vector dot dr vector can be written as integration of f vector dr vector can be written as dr vector divided by dt into dt. So multiple and divided by dt. So dr vector divided by dt into dt. Dr vector divided by dt can be written as v vector. So replace that the value of dr vector divided by dt is nothing but v vector. So f vector dot v vector into dt. Integration of f vector dot v vector into dt. The next step is substituting equation 4.41 in equation 4.42 in equation 4.40 we get. So substituting these values, W can be written as integration of dw divided by dt into dt. F integration of f vector dot dr vector can be written as integration of f vector dot v vector into dt. Substituting this equation 4.40 we obtained integration of dw divided by dt into dt is equal to integration of f vector dot v vector into dt. Dt common term. So this term goes to left hand side. So integration of dw divided by dt minus f vector dot v vector into the common term is dt. Remove the common term is equal to 0. This relation is true for any arbitrary value of dt. This implies that the term within the bracket must be equal to 0. That is dw divided by the bracket term dw divided by dt minus f vector dot v vector is equal to 0, or dw divided by dt is equal to rearrange this equation. dw divided by dt is f vector dot v vector minus f vector dot v vector moves towards to right hand side means plus f vector dot v vector. So dw divided by dt is equal to f vector dot v vector is equal to power t. So this is the relation between the power and velocity equation. Very important 3 mark question, children. Relation between power and velocity. Thank you very much.